Okay, now let's talk about an very important topics why we need to know the crystal structure of a material. And one good thing is if we know the crystal structure, we're able to calculate the theoretical density of the given material. Um, as we all learn from physics, density has the unit as weight on the top, either gram or kilogram, right? And it's a weight per volume. So the unit for volume it's meter cubic or centimeter cubic. And we can actually use the crystal structure, the unit cells of a given material to calculate what's the weight of the atoms and what's the volume of the unit cell to calculate the theoretical density. So the equation to calculate density is rho equals NA over VC NA. Right here, N it's number of atoms inside of the unit cell. And A, it's the atomic weight of the given atom. VC here is the volume of the unit cell. NA inside of this equation, it's Avogadro number. It's a constant. The value of Avogadro's number is 6.022 times 10 to the 23rd atoms per mole. Okay, so those are all the information you need to calculate theoretical density. Let's look at an example. As we all know, copper has FCC structure. And previously we learned FCC is pretty dense, right? It has APF of 0.75. And here let me give you something we know about copper. So copper has atomic radius, which is R, equals 0.128 nanometer. So this is the radius of the copper atom. And it has FCC crystal structure and the atomic weight A here for copper it's 63.5 per grams per mole. Okay, now those are all the informations we know. We want to find out what it is the theoretical density of copper. Okay, now we can apply the equation there. Rho equals, copy the equation NA over NA times VC. Okay, if you still have the table of the summary between different crystal structures, we would know a FCC crystal structure. Inside of FCC, there are 4 atoms per unit cell, right? And so the N equals 4. A is given here, which is 63.5, that's grams per mole. And Na on the bottom here, it's a constant number, so we copy that number. 0.022 times 10 to 3 atoms per mole. Okay, let's add unit for our number 4. So here 4 should have the unit of atoms per cell, right? And we have one more thing, that is the volume of the unit cell. And there's a relationship between A and R. A and R for the FCC crystal structure, right? So for FCC, A equals 2 R square root 2. So this is a relationship between A and R. And we know the volume of the unit cell is going to be, take the cubic, A cubic. So here on the bottom, the volume of the unit cell is going to be 16 square root 2 R cubic. Right. Remember, the R here is given. We know R, the value of R is 0.128 nanometer. And yep, that's all the information we have. One thing to be careful is make sure you put units for the values. Otherwise, you're confused and get lost. Okay, how about let's put our density in terms of grams per centimeter cubic. So when you do the theoretical density calculation, you want to make sure your new unit are consistent. Since here we want to have grams per centimeter cubic, we have grams here, so leave that as it is. And here we have nanometer, because R is given in nanometer. You may want to convert that nanometer to centimeter in order to end up with grams per centimeter cubic. Okay, let's look at how could all the unit cancel off. So we have atoms on the top here. Atoms, they can cancel. We have more, it will cancel. So what you end up with, it's grams per volume. If you do the calculation right, let's compute this to the row. Because the theoretical density of copper ends up with is 8.89 grams per centimeter cubic. And if we look up and the measured density of copper, which is very similar to this value, and okay, hopefully this is the example to show you how to calculate the theoretical density of a given material. And again, the information you'll need to calculate density includes number of atoms per unit cell, that's N. This information is related to the type of crystal structure of the material. So make sure you understand which material you're talking about and what crystal structure it has. And atomic weight, you can find out that from the periodic table. And the volume of the cell, unit cell, You can calculate this if you know the length of the unit cell. But if you don't know the length of the unit cell, you can always look up what's the radius of the atom for the given material and find out the relationship between A and R in order to calculate the volume of the unit cell. Next, information is a constant, so you can just write this on your cheat sheet all the time, and Na is 6.022 times 10 to the 23rd power. Okay, that's all you need to calculate theoretical